Hey everyone, I'm Joe and I'm going to be introducing what the RMCCDC is. So the Rocky Mountain Collegiate Cyber Defense Competition, or RMCCDC, is an annual information security conference hosted by Regis University in Denver, Colorado. It takes place at the end of February each year. What it is part of the national CCDC competition, in that it is a qualifying round to go to nationals. It's also a collegiate undergrad competition, so because UNM mostly sends graduate students, we're not actually competing. We're just there as a learning experience. So the nature of the competition, so it's an information security competition where it's a red and blue team based thing. So where a red team attacks a blue team. So the purpose of that is you need to defend your system and maintain normal operations. And the competition is it's half business and then half technical. So part of it is running basic system administration tasks or keeping your services up, and the other half is like writing injects and doing customer service. So that's what the RMCCDC is. I'm going to pass it off to Connor, who's going to talk about systems we encountered.
Hello, my name is Connor Brown, and I'm going to be talking about the systems that we encountered. So when we walked in the room, we had direct access to 4 laptops. 3 of these laptops were Dell laptops running Windows 7, and the last one was a MacBook OS X running Lion. The Windows laptops, it's worth mentioning, they all had VMware vSphere installed, which is how we had access to the rest of our systems that we had to keep up. And then we also had direct access to HP LaserJet printer. This was a fairly large printer. We could use it for printing out whatever documents we need. It did work. We're also in charge of securing that because they could exploit us through that. However, that was not one of the services that they had up and running. Telephone, we did have access to a phone in the room that the customers called us through to let us know that we had problems. Also, Encase was installed on one of the Dell laptops. This software was used the second day for a specific problem that they gave us. That's also worth mentioning. So these were all the VMware vSphere clients that we had access to through VMware. We had 2 database servers running CentOS, and we also had 2 web servers running CentOS. And something worth mentioning on the next ones, the domain controllers, they were split up on 2 different forests, so they were on 2 different sub-networks. So those were both running Windows Server 2K8 version R2. We also had a Splunk server, and we also had a mail server running Windows Server 2003. We had an FTP server running CentOS. We had our own cloud server, which is a cloud storage server. And we also had 2 Windows XP client machines. So these were all the machines that we had access to through the VMware vSphere. And that's all that I have. Up next is Mark.
Hi, my name is Mark, and I'm going to be talking to you guys about the hardware that we encountered at the competition. So to start off, there was 3 HP laptops. One of them was a forensic laptop. So we dedicated that as a machine that we used for the forensics inject. The next was the inject machine, and that was one dedicated to writing all the injects. The last HP laptop was used to investigate and protect the network. So basically, that was a machine we used to connect to all the other VMs and set passwords and things like that. We also had a Apple laptop, and this was also used to investigate and protect the network. So again, it was a machine that we used to connect to all the VMs and set passwords and all that kind of stuff. We also had an HP printer that wasn't part of the services that we had to protect. It was just something we used to print all our injects and everything. We had a Cisco switch that was used basically just connecting all our hardware was connected to that switch. And lastly, we had a phone, and that was just used to facilitate the help desk. So next is Valerie with Injects.
Hi, I'm Valerie, and I'm here to talk to you about Injects. Injects are basically what they called reports to the CEO. The CEO would write us an email and ask for us to research something and give us a security recommendation, and we'd have to format that into some sort of report and put it in by a certain deadline or a certain amount of time. Different amounts of times for different injects. Some of them were not due to the very last day, but we got them on the first day, well, the second day, and some of them were due in an hour, so it was variable. one of them, very first one, was due in 1 hour, and so you want to keep your eyes open at the very beginning. However, since they worked with the CEO, format was very important. The grammar and the spelling were important and graded, as we're having something consistent each time. They wanted to include the number of the inject in the body of the inject, as well as the team number in the body of the inject, to make it easier for grading, and just a general level of professionalism. So they were usually done in Word and then converted to PDF format and submitted electronically. So they did end up tying up a computer system while they were being formatted. We sometimes would write them by hand first, so that it was just typing up at the end, so that some of our limited computer resources could still be used for things like protecting our systems and changing passwords. So there were a couple different types of injects. There were ones that were recommendations for new services. For instance, what services of ours should be changed to the cloud, and whether or not phishing training for users is terribly valuable and how to go about it. Others were for policies and procedures. They wanted to know about our change procedures, how we implement a change, what process we go through to validate it and make sure everyone's aware of it. And also things that were record keeping, basically, like a password list and a change log, and also a list of all the customer service things we did throughout the course of the 2 days. We got a pretty high score on that because we kept a list, but some of the other teams actually, or one of the other teams, did a ticketing system, so that might be useful for the future. As you can see, different injects had different points, and so you can't really know ahead of time what's going to have a lot of points, but one pattern I noticed was that the sort of basic record-keeping injects were only 10 points, and those password changes and change logs took a very long time to type up in Excel, and so it seemed like the amount of time that got spent to the total possible points to earn was a bit of a discrepancy there, so that was unfortunate. But as you can see, there's a wide variety of injects, and the MK slab counted as an inject, so that was another part that went into the overall scoring. And cryptocurrency recommendations, where we did best, probably because of Ryan's previous knowledge. So it's difficult to study ahead of time for these because they cover such a wide range of topics, but you do have access to the internet, Wikipedia, and other sites, and so it's good to have a basic knowledge of security and then just go and do a little bit of quick research when you actually get there. Alright, I'm going to pass this along to Dustin, who will be telling you about some of the types of attacks we encountered.
Hi, my name is Dustin. I'm going to talk to you about the type of exploits we encountered. First, I want to talk about the Zeus botnet. That was preloaded in our network on one of the Windows XP machines. This was used to install keyloggers on the workstations that we were having and to establish persistence on the Windows servers. Zero-day exploits. All the systems we encountered, our workstations and our servers, were really behind on patches. No service packs, no security patches at all. So we were vulnerable to pretty much everything out there. TCP overloading, this was more specific to the Linux systems. This was done to establish root persistence. Once they had it, they established many backdoors. We didn't find them all. Telnet was one of the ones we did find, run on port 23. Password exploitation. We had problems with databases as well as host systems. The password on all the boxes when we got there was password. The red team used this to exploit and install persistence without even having to use any real exploits. And then unsecure firewalls. This was a problem because once they had figured out the password to our databases, even they were able to connect to that. So we'd be changing the host name. They still have access to the database, but because we had the port open. So that's really what they used to exploit us. Up next is Kat with the results.
Hi, I'm Kat, and I'm going to be talking to you about the results and the scoring engine that was used for this competition. Overall, we actually got 6th place in the competition out of 8 teams. We got 5th and 6th on our services and SLA violations. That was done by a scoring engine, which I'm going to talk about in a minute. And then we got 4th place on our injects. And we got 8th place on our incident points, because we didn't really understand what they wanted. So hopefully next year that can be clarified. So the scoring engine used a complex formula to score our services and our SLA violations. The Injects were actually scored manually by a group of white team members. It made it less subjective by having so many people grade it. And then we actually got to see live updates on our team site for our own services. So we knew if our services were up based on a green color, we knew when they were down based on a red color. However, we had a 10 to 20 minute network lag, so it could take a while before we knew something was down. This is a breakdown of all the services that we had to maintain and how they were scored. We earned points for the percent uptime, and then we lost points for our SLA violations. And then our Inject breakdown, they were each graded individually. And I just wanted to note that we did really good on most of our Injects. We just had 2 zeros in here. Our forensic NCASE lab had a 0, and we're not really sure why because we turned it in. And we're pretty certain that we had some of the answers correct, if not all of them. And then our network printer we got 0 on because we couldn't get an IP address configured before the deadline. The printer got stuck in a reboot cycle. Okay, well, I'll turn it over to Christy with strategies now.
Hi, my name is Christy Gross, and I was the team captain for the UNM RMCCDC team this year, and I'll be talking to you about the strategies and the plans that we used. We essentially had 2 different strategies. We had the one that we created beforehand, and then of course when we got into the room a lot of things changed, so we had to come up with the second strategy. Initially what we had done was we had split team members up by their technical skills and areas of interest. So each person had 1 or 2 topics that were their main topics that they were supposed to understand and learn, and then we all had a backup, so we weren't all trying to learn the same thing. We also had a list of first hour tasks to complete when we got into the room. This changed pretty much as soon as we got into the room because we found a lot of unexpected things. The main thing was a lack of access to the firewall and the switch. We didn't actually get access to those until the second day of the competition. So what we essentially ended up focusing on for our first hour tasks were strong password protection for our machines and also the Injects, which started coming in right away. We always had 1 to 2 people working on Injects at all times. We wanted to have snapshots of all the machines as backups, but we never quite got that working. Throughout the competition, we were never really at a point where we weren't being attacked long enough to get the snapshots installed. The second day, we had to come up with a completely different strategy based on what we had seen the first day, and we did a lot better on the second day. On the first day, we had been receiving phone calls from customers, I guess that were having issues with certain services. On the first day, we had all kind of been answering the phone and didn't really have a set of instructions on like what to ask and what to say. And so on the second day, we had 1 person designated to answer all the phone calls and to deal with all of the customer service issues. This also included checking a customer service email account that we had. We also got access to our firewall and switch on the second day, and so we made those our priority to get those up and running. We also didn't get all of our passwords set on the first day due to the fact that there were a lot of different machines, and so we, I guess, focused on setting the rest of the passwords. And then also incident reports. As far as incident reports, we weren't completely sure what they were for. There were a lot of technical issues that didn't have anything to do with the competition, and we thought that the incident reports were more for those. But it turns out that the incident reports were also to submit in case we had been attacked, and so we weren't necessarily aware of that, so the second day we had to turn in a lot of incident reports for the first day. We also found a lot of unexpected things in the competition. The largest thing, and I guess the biggest problem that we had that contributed to, I guess, a lack of ability to cover multiple things at once was that there were only 4 machines. There were 3 Dell laptops and a Mac for 8 people. So, you know, there were only half of us on computers at any given time, which caused a lot of efficiency problems. The second thing was there was an enormous network lag through the entire competition. On the first day it was about 10 minutes, on the second day there was about a 20-minute lag, so we couldn't really see our scores, because that was 20 minutes behind. A lot of our machines were extremely slow. They either didn't boot up or they froze, and then it would take 20 minutes to boot up because of the network lag. And then we also found out that the machines already had backdoors installed on them before the competition even started. So we went into the competition already under attack, and so it was more of like recovering the entire time than actually being able to set up a defense. So next I'm going to introduce Ryan. He is going to talk about the lessons learned.
Hello, I'm Ryan Dello, and I'll be talking to you guys about the lessons learned. One of the most important lessons that we learned during this competition was that we should have regrouped at the beginning of the competition. We came into this competition with all kinds of expectations as to how we were going to be scored, what the infrastructure looked like, things like that. But once we actually got there, we were able to get familiar with what our environment actually was. So we should have regrouped and reassessed what we were doing, possibly prioritize certain tasks first, knowing what we were working with as we walked in, rather than just continuing our plan. We should have had an inventory of all of the systems. So we had basically a checklist as to what we wanted to do, but we should have had a checklist for each system we had. For example, we should change the password, install anti-malware, things like this. And that's just a generally easier way to keep track of things, and this kind of threw us off on our passwords. There were only 4 machines we could work on, and 8 of us, or more than 4 VMs, so it was a little difficult to know which passwords had been changed, which systems had malware, anti-malware installed on them. So we missed easily fixed vulnerabilities by doing that. There were just processes running that said bot.exe that we would have caught if we had checklists like these. We should have used anti-malware and intrusion detection, and to reiterate that, we had the plan to install anti-malware and have intrusion detection. However, the problem happened with whitelisting. We weren't allowed to access any website that we didn't submit to the whitelist. So if we wanted Malwarebytes, we did submit malwarebytes.com as the whitelist site, but the download link was not whitelisted, so we never ended up getting these kind of programs on our systems, third-party programs. So I think the major lesson learned here is to kind of understand how that white page and whitelisting works. Incident reports was one of the largest problems we had, and after the first day we found out that it was a problem across all of the teams, and so they had to say something about it. What we took the incident reports as was, if we had a problem that we couldn't fix, we submitted an incident report. Like, this isn't a legitimate incident with our team, we can't fix this problem. What they wanted was a report for every attack that we had on our network in detail. Who did the attack, when it happened, things like that. So we were just off completely as to what they wanted in the incident reports, and that really hurt us in the score. We should have had backups. So we had plans to have snapshots of the virtual machines, and they offered to revert or restore virtual machines as well. But we never backed up databases, web pages, and file systems. That was probably pretty important, because with the persistence that they had, just reverting to a snapshot wasn't enough. We would need backups to those databases so we could swiftly restore things and try to fix it from there rather than going through a long process. And lastly, we should have checked our Wi-Fi. That was probably the most obvious mistake we made. We didn't realize until the end of the second day of the competition, that we had a team Wi-Fi, and the red team changed the password. So just simple things like that we should look out for that are kind of unexpected, and we never used it, so we never came across it, and that's important. Thank you guys. It's the video. Now I'm going to pass it off to all of you guys at this year's CCDC competition. May the best of luck be to all of you guys.